Hey everyone, I'm Silas, and welcome to Psilocybology. Let's expand our mind. This is a series where we take a deep dive into the research on psilocybin, the psychedelic prodrug found in magic mushrooms. We'll be breaking down and discussing the scientific literature, one study at a time, from past to present. Today's episode is on the article titled Controlled Sensory Input, a note on the technique of drug evaluation with a preliminary report on a comparative study of Sernyl, Psilocybin, and LSD-25. The researchers of the study came from the University of Michigan, Ann Arbor, and the University of Washington. As you might have picked up from the title, this is a brief preliminary study, and the purpose of the paper was primarily to describe a novel technique using sensory control during studies into hallucinogenic drugs. The researchers of the study spend the introduction talking about what was then emerging research coming from McGill University on sensory deprivation. Sensory deprivation is when you reduce or eliminate one's ability to perceive the world through the use of tools that can be as simple as blindfolds or noise-canceling headphones, or as complex as sensory deprivation tanks, which are filled with warm water and can be sealed so that they are pitch black inside. Once you're in the tank, you are suspended in water so that your sensation of gravity and temperature are reduced. In the case of this study, the researchers utilized some of these tools not to totally eliminate sensory perceptions, but to very strictly control the sensory environment for the participants so that each participant was exposed to the exact same environmental stimuli. The goal here was really to highlight the differences caused by drugs themselves and to remove variations in the participants' environments where possible, particularly given that their drugs of interest are known for altering perception. So, what was the novel technique the researchers set out to describe? The participants in this study, which I should mention were 4 male and 4 female college students over 21 years old, were loosely strapped to a foam rubber pad and had their hands placed in cotton mitts. The goal here was to minimize body movements where possible. To control auditory perceptions, participants listened to white noise through noise-canceling headphones. To control what the participants could see, they placed a 36-inch, or about 91 centimeter, sandblasted acrylic glass semisphere 12 inches, or about 30 centimeters, from the participants' eyes. This was essentially a milky-colored bowl that completely covered their visual field. Interestingly, this tool was used to study the Ganzfeld effect, and was even referred to as a Ganzfeld semisphere by the researchers. The Ganzfeld effect is a phenomenon where, after long periods of being exposed to a perfectly uniform visual field, an individual begins to experience a sense of blindness, where their visual field goes black, or they experience hallucinations. This is different, although related, to what are known as Ganzfeld experiments, which were experiments attempting to test for the existence of telepathy and other forms of extrasensory perception. Research into the Ganzfeld effect began roughly during the 1930s, whereas the Ganzfeld experiments were being conducted in the 1970s. So prior to being placed in this controlled environment, the participants were given a liquid that contained either Sernyl, psilocybin, LSD, or placebo. This study used a within-subjects design, meaning that each of the 8 participants received each of the 4 test conditions, or in this case, the 3 drugs and the placebo. Importantly, the researchers said that the order the drugs were administered in were the same across all participants, such that they each received 20 milligrams of psilocybin during the first trial, 150 micrograms of LSD in the second, followed by a placebo, and finally 10 milligrams of Sernyl. The limitation in not randomizing the order across participants is that it's possible the effects of having taken one drug might influence the effects of subsequent drugs. One example could be through developing drug tolerance, but another could even just be your expectations going into the experiment. If you had perceptual alterations after taking one drug, you might begin to expect these same experiences in the subsequent trials. This expectation could mean you are paying closer attention to your senses, and possibly mean you will spend more time questioning which experiences are normal and which are not, ultimately increasing your reporting of symptoms. It might also have you focus in on the experiences that you've had in prior trials and overlook or ignore some of the other sensory perceptions that are happening. The researchers did, however, make sure that the participants were unaware of what drug they were taking by masking any differences in flavor using cherry syrup. Taking one quick step back, Sernyl is the branded trade name for the drug phencyclidine, or PCP, also sometimes referred to as angel dust. I'll be referring to it as PCP for the remainder of the episode, since I prefer to call something by its actual name rather than a brand name. PCP was originally used as an anesthetic until it was banned in the US for use in humans in 1965, 5 years after this study was published. It has some similarities to the drug ketamine, since both can cause dissociation and hallucinations. However, PCP has been known to have less tolerable side effects. Once the participants have taken one of the 3 drugs or placebo and are placed in the sensory-controlled environment, they are then played a pre-recorded set of instructions through their headphones. Throughout the duration of the study, the participants are only ever exposed to pre-recorded audio stimuli, so that each participant always hears the exact same thing. Participants are also told that although no one else will be in the room with them, they will be continuously recorded and thus should report any feelings they consider unusual. The first phase of the experiment involved a set of recorded orally administrable tests that evaluated working memory, perception, cognition, and imagination. The researchers unfortunately don't describe what the tests involved, so we aren't able to evaluate how valid or reliable these tests might be, which will be good to keep in mind when looking at any results. They did, however, say that these tests took 20 minutes to complete, and that they administered the same battery of tests 3 times consecutively over the first hour of the experiment. The aim was to determine how the onset of each drug impacted performance. Although having these repeated assessments is interesting, the first and second time through the tests can definitely influence how they perform on the second and third attempts. Following the first hour of tests, participants were then exposed to nothing except white noise for 45 minutes. Subsequently, the participants are asked a series of questions about their experience and symptoms for 10 minutes. The final part of the experiment involved 30 minutes where participants were presented, quote, ambiguous, provocative stimuli. The results presented in this article are extremely high-level trends, since the purpose of the paper was really to spend more time discussing their use of the controlled sensory environment. The researchers noted before going into the results that, quote, detailed data will be presented in a subsequent paper, although I did not come across any such paper. I feel like a good rule of thumb in general is not to refer to papers that have not yet been accepted for publication. So what they do report in their 2 paragraphs of a results section was that they found that both psilocybin and LSD produced hallucinations and delusions, but that psilocybin was reported as being unusually pleasant, whereas LSD was reported as being unpleasant, anxiety-provoking, and disruptive. Personally, I think this may have partially, although not entirely, come down to the differences in dose. For psilocybin, 20 milligrams is right in between the range of 10 to 30 milligrams given in many modern trials, and is a bit below what is often used for recreational purposes, although there is a lot of natural variability among mushrooms. For LSD, 150 micrograms is at the higher end of the range of a standard hit, which tends to fall between about 50 to 150 micrograms. If this was the first time these participants took either of the drugs, to me it would be understandable that they found a more pleasant experience on a lower dose of psilocybin compared to a higher dose of LSD. As for PCP, the participants rated it as being very mild, having less of an effect than what they reported after being given placebo, with the only reported symptom being minimal body image disturbances. Now this was pretty shocking to me because they said they administered 10 milligrams of PCP, which is a substantial dose. Doses between 10 to 15 are often considered strong. They did mention that PCP was the last drug to be administered, so it's possible that some cross-tolerance might have occurred, where because they had taken psilocybin and LSD previously, they would have needed a higher dose of PCP to feel the same effect, although that's just conjecture. Since they only discussed the results at this high level, it's also hard to take a look at the quantitative effects of PCP. Overall, there were 2 key points that the authors claim can be made based on their findings. The researchers note that prior work on psilocybin and LSD have primarily found their effects to be indistinguishable. In this study, however, there were discrepancies in terms of how pleasant or unpleasant each of the experiences were. They claim that this difference was able to be teased out due to their control of the sensory environment, namely that without interference from interpersonal and situational factors, the drug-induced alterations of psilocybin can be distinguished from LSD. The second claim they make is that because both psilocybin and LSD influenced sensory perceptions, even during periods where participants were only exposed to limited stimulation, these drugs must increase firing of neurons in the sensory pathways independently of external stimuli. The researchers then conclude the paper by advocating for the use of similar controlled sensory environments to study psychotropic drugs, as it can help distinguish the factors that influence their effects. Personally, I think the concept is quite interesting, and I'd be curious to see if this could even be used in treatment studies. In a lot of modern-day research, you might see some psychedelic medications being co-administered during psychotherapy. I think a potentially interesting study could examine treatment outcomes using 4 conditions, where one group of participants are given a placebo and therapy, one group is given psilocybin and therapy, one group is given a placebo and placed in a sensory-controlled environment, and one group is given psilocybin and placed in a sensory-controlled environment. It would be an intriguing way to try and separate out the effects that are due to psilocybin, therapy, and both combined. That's it for today's episode. I know it was just a preliminary study, but I found it really cool to be able to see the types of experiments early researchers into psilocybin were conducting. As always, I really hope you enjoyed the show. If you have any questions, feedback, or ideas for the show, please let me know. You can find out all of the ways to reach me on the website, psilocybology.org, where you can also find the full transcript for each episode if interested. Thank you all for listening, and I'll talk to you next time.